welcome to the Kubernetes Security and Observability Summit presented by Tigera. Today's topic of discussion is ensuring adequate security and compliance for microservices and cloud-native applications. I'm your host, Amit Gupta, and delighted to introduce our guest, Saikat Maiti. Saikat has more than 20 years of experience in information security, compliance, and data privacy. He led the information security practice on West Coast for PricewaterhouseCoopers. He owned the security and compliance charter for various VMware products. Very recently, he had the security leadership role at Personal Capital and Upstart. So he has this unique background where he has worked with modern born-in-cloud companies, but also some traditional organizations, enterprises, and really, this should be a very fascinating discussion for our audience. Saikat, welcome and thank you for joining us.
Thank you, Amit, for having me over today and for this opportunity to share some of the things that I have seen work in the field at various cloud-native companies in the past. As you mentioned, my name is Saikat Maiti. I am a senior director with the Critical Product Initiatives Group at Salesforce. We deploy mission-critical information security initiatives to Salesforce customers. By the way, I don't know if you know that Salesforce has set a firm requirement for all customers to use multi-factor authentication starting early next year. And I'm currently leading this adoption initiative for Salesforce. So President Biden has actually reinforced through an executive order the importance of multi-factor authentication recently. And I think some significant adoption is coming our way, from our customers based on this as well. So thank you for having me over, and I'll be happy to share some insights from what I've learned in the past.
There you go. Security driven by White House. So, Saikat, let's jump right into the discussion. Tell our audience, what are the key fundamental differences between cloud-native architectures and the traditional architecture, and really how to think about from a security and compliance perspective across these two different ways of building and deploying applications?
Traditional architecture, for applications typically involves 3 tiers, as we all know, and they're typically bucketed and called as monolithic architecture, And some of their main characteristics are that they typically run off private data centers that have been built with enough capacity to handle peak loads for them, right? And then they also have fixed structures like fixed networking, fixed IP addresses, very infrequent rollouts, because rollouts are, it's almost like you have to coordinate a variety of things to come together for a rollout. So some people had annual or biannual rollouts for their traditional apps, and very long-lived apps, pretty much. These apps used to be there forever. And the low change for the application meant low chances of pushing in a security patch at times as well, which created additional risk for these apps. Now, cloud-native architecture is completely different from this. It's grounded in containers, microservices, dynamic orchestration. So change is the name of the game when it comes to cloud-native applications. And then because you decouple the binaries needed by the application from the underlying host, they are extremely portable. Cloud-native applications can be redeployed at a variety of situations. You can move them across clouds, whatever be the case, right? It just becomes much more easy to move them. Also, they are used immutably. They don't change once they're deployed, which means you can rebuild and redeploy as many times as you want to. and that actually brings in some very interesting dynamics for everybody. Also, jobs for cloud-native applications are, typically deployed when the load spikes and are killed when the load actually goes down. So it's the end result is there is extreme amount of reuse and sharing of underlying hardware and networking. They are not like the private data centers of the past. So that's there. And then the final thing that I'd like to note is they have common build and distribution processes. And since these are standardized, even though different teams are managing and maintaining microservices, they all use the same process and that makes it much more easier to deploy things through that process if you can leverage the process to deploy those things, including security controls out there. So when it comes to security and compliance based differences for such architectures, there are some things that I would like to share with you. I think the first phenomena that many of us may have heard is what we call shifting left. And what shifting left means that in cloud native, security has to be lightweight, continuous, automated, and embedded into the deployment lifecycle. Only then they will be used, or else they risk the situation where people may bypass them. If you don't meet all of this criteria, your developers will most probably bypass it because the velocity of change requires them to, do all of these things at once and then deploy it out there. We have companies like Amazon and Netflix and others who have thousands of deployments every day. So, this is extremely important to have it automated and embedded into the deployment tools so that the security posturing can be brought into effect. The second thing I want to point out is that traditional fixed routes, gateways, endpoint agents, these are not available anymore. You're talking about the forefront of this, of your threat is now your cloud data center that is deploying your container. So you have to go in and secure them, So attack detection has to be near real time, if not real time. It has to be extremely dynamic. It has to scale with the loads. It has to have no visible cost to performance and scalability, but yet be there for you, as part of your security strategy. And that's also very important. And there's a need to integrate, visibility, monitoring, and protection across this hybrid stack of Linux hosts, virtual machines, containers, application services to kind of have a well-orchestrated strategy. So orchestration is the name of the game. Observability is the name of the game when it comes to, security and monitoring of cloud-native workloads. So I would say that these are the fundamental changes that are required for security to work in cloud-native workloads.
That's great, Saikat, and some key guidance that you talked about: shift left, embedded, continuous, automated security. I mean, those are some very, very critical principles. We've certainly heard that from some of our users, so it's great to hear that from you as well. Now, if somebody does believe in those models and that paradigm, and they are getting started with their cloud native applications, what would be the key controls, considerations that you would guide them to? Obviously security, there's so many things users can do. So give our audience a little bit of a model of how to prioritize and what to think about from a security considerations for these new modern applications.
When you think about security, specific things that you can do for this cloud native architecture, one of the most important things that you can do is make sure that there is no inherent mutual trust between services. Service isolation or whatever you want to call it, make sure that one service does not inherently and mutually trust the other services out there. And only known and trusted and specifically authorized callers can utilize the service. So these are like some fundamental bread and butter techniques of making sure that you're securing your services out there. Then this helps a lot. It stops attackers from using untrusted code to access your service, and stops them from expanding their reach beyond that service. If they say have compromised one of your services, they would not be able to get to the other services, and limiting what we call the blast radius in the event of an exposure. So this is extremely important. Then also, the other thing I like to point out is use a perimeter approach for protecting your network at the edge. This wall-based approach has been used in the past, even in traditional architecture as well. But, you can have this extended to a microservice level instead of a physical hardware or a network level. And then with service segregation that we talked about, separation and no trust, you can have these walls built with your microservices so that you can have you can constrain service identities to use only authorized code and configurations that run only in authorized and verified environments. So that's the end goal that you can get to. Also, you may have to define and build choke points where you can put in or insert security policies, monitoring mechanisms, and things like that, so that you know exactly what is going on in your environment. And finally, we talked about this a bit in the earlier part of this discussion, is when you standardize the change rollout, and when you automate it, a beautiful thing happens. Everything goes through that same machine, and you can also insert policies and checks in that machine to make sure everything goes out clean. So that is another thing that I point out. And finally, isolate workloads, sharing an operating system using service level isolation and network isolation. So that's I think something that most of the providers of containers give you an option to, and you can do more about it with products like yours, I guess. But yeah, so those would be some of the main things that I would like to highlight that can be done for security and compliance.
No, that's great, Saikat, and really want to chime in on a couple of points there. Establishing the trust between services based on certain key criterias or principles, whatever your organization needs to, is important. Limiting the blast radius and also bringing the security controls to as granular level is certainly a very, very good security practice. Now, Saikat, if we extend this model, I mean, we talked about security approach considerations. Give our audience some guidance around what you have seen with respect to compliance challenges with these cloud native applications, and how does compliance for these applications differ from what folks may have been doing with traditional applications or traditional architectures?
Compliance till now has been an interesting thing. It's been great because independent auditors would come and take a look at what's going on and make sure that you are doing what you do. That's the name of the game with compliance. And the traditional means have worked with the monolith architecture because things did not change much. So a typical auditor would show up, you would take 6 to 8 weeks to do an audit, a report would come out in maybe 2 to 3 months, and most of it would hold true in that kind of an architecture. But when it comes to cloud native, change is, as I mentioned, the velocity of change, the velocity of deployments is so high that a traditional audit would highlight things in an infrastructure that has fundamentally changed maybe in the last 2 or 3 months. So all the issues that come out, all the remediation and the prioritization that goes in may be misfiring if you go with that kind of reporting even today. So what you need as a compliance professional is a real-time view of what is going on. And when you can't get that very easily, at the very least, you want to have some preventative strategies to go in and protect the environment. So one thing that I point out to people is, especially in compliance and audit, is audit the things that don't change in this immutably deployed, architecture. Things like, what are the base templates? Are they approved? And, are the approved templates up to not? Are they, have they been patched? Are they compliant with whatever regulations you're supposed to comply with? And things like that. And that changes, that is what is going out in production, and that kind of gives the auditor control to make sure that the environment is, 1, compliant, 2, secure, and 3, can be relied on, and there is assurance for a senior management from it. So I think that this aspect has to kind of be built out. I know a variety of tools are coming in to help continuous audit, automated continuous audit, and I think those tools will really make a big difference for our compliance folks because it will give them the visibility that they need as of today, and not what happened 2 or 3 months back.
And I think, Saikat, you said it a few times today, but it's worth restating for our audience, particularly those who don't have a lot of background working with regulated programs, certifications, that compliance without thinking about how you're going to run your audits is only half the story. And you definitely want to design for some audit scenario, so how you're going to run your audits, how you're going to do evidence collection for these large applications. So it's important to think about audits as well when you're thinking about compliance. So kind of staying on the same topic, Saikat, how about giving our audience some best practices to ensure this continuous compliance and an automated compliance for these modern applications?
One of the best practices that I point out, be it compliance, be it security, let's in this cloud native world, let's remember that there is no such thing as a separate security or separate compliance function. The development team, the compliance team, the security teams have all merged together in this continuous deployment process, continuous integration process that we have. I call it continuous security and compliance process. That has to be brought in together. So, and this process, that we're talking about ensures things like making sure service templates are baseline, standardized, and audited and approved by a central group. So developers can bring in a variety of third-party tools, third-party open source software, and things like that, making sure that this software has gone through your standards and your security policies and your compliance policies is something that should happen as part of shifting left. So as soon as they come in, they should be kind of going through this funneling mechanism, this choke point where policies get applied, things get reviewed and approved, and then get standardized, and then get introduced into your pipeline, into your CI/CD pipeline. And that is where I think, compliance folks will have a say, they will have an approval, they will have a seat at the table. Security folks will have a seat at the same table as the developers who want to propose a change. It sounds a little intimidating, but it is not. Just having worked at two startups, I can tell you that it becomes very easy when people know what they need to, the three things that they need to do to get the stuff into production. And once that gets, evangelized and everybody understands it and the process gets adopted, it's just something that this is how the sausage is made after that point, right? So things just go in and then show up in production, and things are very seamless and efficient. So.
Well, Saikat, this was great discussion. Thank you for sharing all of these insights about security and compliance for these cloud-native applications, some of the blueprints and approaches. Hopefully, our audience got some very strong takeaway from this discussion. Now, obviously, this cloud-native world is very dynamic and it's changing fast. So, Saikat, give our audience what you see in terms of future, what lies in the future with respect to security and compliance approaches changing, and how should folks design for future as they get on this journey?
Well, I think the future is headed towards a place where containers and cloud native security and cloud native architecture is here to stay. The benefits of such an architecture, the portability, the ability to deploy and bring change in small steps really quickly. These are things that the industry has tasted, they like it, it's going to stay, this is going to stay forever. So for compliance and security folks, I have, this vision that the future is really bright, because now what we all wanted, I would say this, without any hesitation, that every security and compliance person that I've known wanted real-time visibility and could not get it. And cloud native architecture gives them this option to get it. And that's why I think if we invest, as security and compliance folks, if we invest our time in adopting these tools that foster deployment of such real-time visibility in the environment, we will all benefit from it. The industry will benefit from it. We will be able to stop attackers much more quickly and keep our customers and our user data much more safe in the future. So I think it is time for us as the security and compliance folks to get into the game, get into the ring fence, understand what are the tools that make our life easy, and if there are missing tools, bring in those tools through requirements and asks of the industry, and get them deployed so that we get to be this real-time force that stops attacks and avoids exposure. So really positive about what's going to happen in the future for compliance and security folks.
That's great. And if we do all of that, then we stay on the right side of the White House as well.
Exactly. Right. Amit, yeah.
Great. So, Saikat, this was great discussion. How about in a true spirit of fireside chat, we close our discussion with some rapid fire questions.
Ooh, rapid fire, huh? All right, let's do this, Amit.
So let me start with this. Saikat, if you had the power, uh, what term or concept or fad you would prohibit from container security?
There are a lot of buzzwords in this particular space. We have heard a whole bunch of buzzwords in the last few years, but there's one that just did not make sense to me. One was the one that I was talking was serverless security, and I don't understand what that is. So, and in most cases, when I kind of tried to scratch the surface around this, I didn't get anything meaningful. I know that serverless is a big thing going on, but serverless security, unfortunately, does not make sense. So that would be one of the things that I think I would try to prohibit in the future from being added into our lexicon out here.
The next one, when a DevOps mentions fill in the blank, it drives you up the wall.
So again, another fad, I guess, I don't know, but this whole thinking around AI or artificial intelligence and deep neural networks making life easy in everything, including CI/CD pipeline management. It's one of those things that I've heard a bunch of people speak without much substance behind it. And I think that's one more thing that I think we need to flush it out. I'm pretty sure that maybe use cases where artificial intelligence may help, but I have not run into one such use case that will help CI/CD pipeline management any better. So yeah, that would be one of those things.
All right. If containers or Kubernetes pods or microservices could talk to humans, what would they say to security or compliance teams?
They would say one word to us: prevention is better than the cure. So prevent threats by standardizing stuff, by architecting better controls. So make sure that you review and approve and understand what is going to happen in your environment before it happens. We have seen this extreme focus on detection and automation of detection. And unfortunately, that has led us to a place where we see thousands of false positives in the security arena, right? And that burns out security teams. We build armies. We don't really get the results that we want to get. And I think what container and microservices based cloud native architecture gives us the option is to standardize, to bring it, as I keep saying, shift left and bring things out there to prevent rather than detect, So that would be what they would tell us, I guess. That's the spirit of security and compliance for us from microservices and containers.
It's a recipe for disaster when DevOps and security fill in the blank.
That they decide, both of these teams decide that it is not their responsibility to secure containers. Each of these groups think that the other group will do something to secure the environment, and they would kind of hope that the other one is doing what is required and not do their bit. So it just becomes very difficult. As I said, this is not one group can solve for. This is every group getting in together and defining a much more robust process and a set of tools that incorporate itself into this continuous development, continuous monitoring, continuous deployment, continuous security environment that we're talking about that is fully compliant at all times. So I think the recipe of disaster is if people start pointing fingers at each other for fixing things instead of doing it themselves.
Well said. I mean, it's definitely a shared responsibility. Last one, fill in the blank, is as misunderstood concept in container security as pineapple on pizza.
Pineapple on pizza, yes. I think it's an interesting question, Amit, because I think observability and data privacy are typically at loggerheads, because to increase observability, you have to capture a whole bunch of data and metadata and share it, and sometimes share it with not well-defined groups of it. It may go to your SOC, it may go to a whole bunch of other people. And this data, if used for security intelligence, is great because you can stop an attacker on the tracks, but it can also give too much information about your environment, about your customers, and things like that. So it is, it has to be balanced out, and there is a lot that can be done through accurate security policing, as well as some compliance-based principles, policies getting deployed. So that is why, pineapple on pizza gives you acidity if you do not control the amount of pineapple going on pizza, if you even like that kind of stuff, and that's what I like to say, if you don't control the level of observability and the objectives behind the data collection well, it could be pineapple on pizza for data privacy out there.
Well, Saikat, really, really appreciate your time. Thanks for sharing all your insights, the best practices, the models, the paradigms. Hopefully our users enjoyed this discussion and they got some solid takeaways that they can take as they go practice some of these principles. Thank you so much.
Yeah, thank you, Amit, for having me over here. Really enjoyed this discussion and the rapid fire round. Thank you. Bye-bye.